Alright, guys, yeah, welcome back to the continuation of our review of important terminologies in object detection. Today we shall be looking at the non-maximum suppression. Now, the non-maximum suppression is an algorithm that helps to ensure that the model is able to accurately draw a bounding box around object of interest. So what happens is, after you have fully trained your model, at inference time, when you run your model through an input image, your model is going to return multiple bounding boxes, also referred to as detection windows, for the same object. Now, you don't need multiple bounding boxes for one object. You just need one box for one object. So in order to eliminate the duplications, the non-max suppression works in this way. First, let's say it has like five boxes that it predicted for a particular object. It will calculate the probability of each of the boxes whether they contain an object. So based on the probability of each box containing an object, say for instance you set a threshold that any box that contains an object with a probability less than 0.6 will be discarded. So you just discard that, just delete that, eliminate that. After doing that, let's say for instance there are now remaining two boxes. Three has been eliminated in stage 1. Then in stage 2, you select the biggest probability, select the box with the biggest probability of having an object. Okay, so out of the two that is remaining, you select the one that has the highest probability of having the object of interest. Okay, then after that you discard all boxes with a high overlap. Now you've already narrowed down at step 2 to a particular box. You have already picked the one that has the highest probability of having an object. So this step 1 and step 2 is essentially focusing on, we're interested in boxes that has object of interest. Any box that does not have object, we are not interested in it. There's nothing to do with it. So then once you select the box with the highest probability of having an object, you discard all boxes with a high overlap with that selected box using the matrix intersection over union that we considered the last time. What this is saying is, let's say that we have two boxes. The two boxes are accurately predicting the object well enough. The two boxes, we have two boxes that are accurately predicting the object, but one box has a higher probability in terms of the classification. I want us to get this correctly. Each box has the probability of containing an object, and at the same time we are also considering how well each box fits the object. So once in step 2, we have already narrowed down with a box that has the highest probability of containing an object. So that means that box is confident that I have an object inside of me. Then any other boxes that overlap with that selected box will be discarded using an intersection over union between the selected box and the overlapping boxes. I hope it makes sense. It's a bit tricky. Then you repeat this step 2 and 3 until all detections are either discarded or selected, because you are going to have multiple objects in a particular image. So you are interested in all the objects in your image. And that's essentially what it's saying. For instance, here, this we want to draw a bounding box around a car, and at the same time we want to predict the probability that a bounding box has this car. So at model inference, we have these three boxes: the red, the green, and the yellow. Those three boxes were predicted. So what does the non-mark suppression will do? It will first of all discard all the boxes with a low probability of containing an object of interest. So you can see that we have all these other boxes here. These boxes, this other that looks like all this grid. So these boxes, they don't have any object. Let me pick my marker. So you will see that this is a box here. It doesn't have an object of interest. This is another box. Doesn't have. This is another box. All these boxes, they don't have any object of interest, because what you want is to predict this doesn't have, this doesn't have. So all these ones and this one too doesn't have anything of interest. So all those boxes with low probability of containing an object with this threshold will be discarded. So we eliminate all these ones first. After we have eliminated that, then we select the box with the highest probability of having an object. So based on this, we have these three boxes. So which box has the highest probability of having an object? So it comes with each box has that attribute, which is the probability that it contains an object. Then we discard all the boxes that has a high overlap with that selected box, because since we already selected the one that has the highest probability, then we don't want double prediction. So we just discard the one that has overlap with that using intersection over union. Then once we are done with this, for instance, then we go on. If there are other objects of interest in this image, we do the same thing until we are done with this image. And this is implemented in TensorFlow with the name non-mark suppression. Alright, I hope someone has benefited from that. Thank you for listening, and do give us a like, and see you in the next one. Thank you.